So the next construction that we are going to look at is the product topology, right? So basically, if we have two topological spaces, X and Y, right? So then we can consider their Cartesian product, so X cross Y. So recall from Foundations of Mathematics that X cross Y is the set of all possible pairs, X and Y, where X belongs to X and Y belongs to Y. Right, so we are going to construct a topology on this product space, and so notice that this is very important, that we are going to specify this topology using a basis, right? So, and the reason why we cannot say that this is the whole topology is going to be clear in the tutorial. So in the tutorial, you are going to show that it is impossible to say that these are all open sets. So it has to be a basis, and then we get all open sets as unions of basis sets. Okay. Now, so why is that R cross R is R2? So let me explain. So by definition, so what are open sets on R cross R? So what is an open set on R? So usually, I mean, so any arbitrary open set is hard to describe, but basis open sets on R are just intervals, right? So we have an interval like from A to B. So what is a basic open set on another copy of R? So this is an interval from C to D. All right, so it means that if we form all products of an interval from A to B to an interval from C to D, so which looks like an open rectangle, by the way. So it looks like this. So this is A, this is B, this is C, this is D. Then we are going to get a basis on R cross R. Right? So this is our basis for a topology. But then, as we have seen in class, this is indeed a basis for the same topology as the standard topology, right? So this is to specify topology using open rectangles is the same as to specify it using open balls. So this is indeed the same thing. And it is not hard to see that more generally. So if you take R M, take cross R N, then what you will get is actually the same as R 2M plus N. Okay, so my point being is that the intuition here is consistent, so with our common sense. Okay, so why is torus the product of two circles? Here is why. So recall that we saw that a circle is a line segment with two opposite endpoints glued to each other, right? So let me draw this, right? So this is a line segment, and what is the product of two line segments? It is a square, right? So to construct the product of two topological spaces, so this is our S1 is going to be a line segment 0, 1 with where 0 is glued to 1, and the other S1 is also going to be 0, 1, subject to the equivalence relation 0 is glued to 1, right? But 0, 1 is an interval, right? So the Cartesian product of two intervals 0, 1 is a square in the plane, right? So let me draw some x-axis and y-axis. So this is going to be x, this is going to be y. So this is going to be 0, this is going to be 1, this is going to be 1. Right? Okay, so it means that so all possible pairs of points from where x belongs to the interval from 0 to 1 and y belongs to the interval from 0 to 1, they form a square on the plane, right? But then we do these gluings. So we glue 0 to 1 in both intervals. So it means that let's look at, say, this interval. So it means that say this point here is going to be glued to this point here, because if you look at the cross section, then here you see this interval, and the opposite points of the interval are supposed to be glued to each other. So because of the same reason that this point here is supposed to be glued to this point, right? So because they have the same value of x, and the value of y is either 0 or 1, and 0 is glued to 1. And so on, right? So if you think like this point is glued to this point, this glued to this point. So if you think about which points we should glue to which points, you will see that this is exactly the same as this labeling, identifying gluing via labeling along edges. Like this A is to be glued to this A, and this B is to be glued to this B. So which means that this is a torus. So the reason is just because when we draw it on the plane and analyze the gluing instructions that will occur, we will get exactly the same instructions as the standard instructions for a torus. So, which is why the torus is actually the product topology of two circles.